Hi, everyone. I'm Doug Black, editor-in-chief at Inside HPC. And today, as part of our series of Dell Technologies interviews, we are with Dr. Alastair Basden. He is head of COSMA HPC Services at Durham University in the UK. And COSMA stands for Cosmology Machine. And cosmology is the science of the origin and development of the universe, the Big Bang Theory, and all that. So now COSMA HPC Services at Durham is comprised of a battery of HPC systems, and the facility is a Dell Technologies HPC and AI Center of Excellence. Alastair, welcome.
Thank you.
All right, so I understand that Durham is on the path to exascale and that you continually test new technologies. Tell us about some of the technologies you're looking at, as you move toward that milestone in HPC.
So we've got a few things that we're testing, that we're on either the novel technologies or that we're on the leading edge of. So we're always very interested in CPU technologies. We were one of the first a few years ago. We were one of the first HPC facilities to get the AMD EPIC chips, and we have some cutting edge. Well, at the moment, the cutting edge Milan chips. We've got some of those in the lab, which we're looking at. We're also very interested in HPC fabrics. So we are doing some tests with Rockport Networks at the moment, which is a 6D torus network switchless fabric. So we're currently, very soon we'll be upgrading one half of one of our clusters to use the Rockport network. We're also looking at Bluefield technologies, so DPU technologies, and seeing how that can improve our scientific code. So a lot of our investigations really are looking at how we can get more science out of the machines we've got, or when we're designing future machines, really how we can get the best value for money in terms of science per pound. We're also looking at we also have we're also interested in carbon saving. So we have a water cooled system. So on chip, our latest system is on chip direct liquid cooled, and we're very interested in composability as well. So we have a composable GPU system. What this does is it allows us to have a number of GPUs, physical GPUs, which we can then, at the click of a button, just move them between different servers. So if there's a job running that has a demand for a few GPUs, we can provide those. At the same time, there might be jobs that don't need any GPUs, so they can then run on empty servers. And then at some point, we might have a number of jobs that all need the same number of GPUs, and we just spread them out evenly over this system, that sort of thing. So we're interested in those sorts of technologies as well.
Okay, great. And please update us on the cosmology work you and the organization is doing, and the role of HPC moving forward.
So what we try and do with our facility is funded by one of the UK research councils, and the research remit of this council is to do with cosmology, particle physics, astronomy, nuclear physics, black holes, and all that sort of thing. So and our system here at Durham is what we call a memory intensive service. So it has a high amount of memory per core. So our current system has a terabyte of RAM per compute node. And what we look at doing with this is one of the major workloads that we run is cosmology simulation. So we have a simulation start with the Big Bang and explode the universe and propagate that through time. And by tuning different input parameters and different models, so things like dark matter and dark energy and so on, we try and match what we get in simulation with what astronomers see in telescopes in real life. And by doing a lot of statistical analysis, we're then able to fine-tune the input parameters of these models to get a better handle for how the universe is made.
Out of curiosity, would you say that as your work progresses, the Big Bang Theory is increasingly validated, or are there holes in that theory?
It's not that there are holes or it's validated. It's just bits of it that we don't understand. I think there's always these unknowns. So we don't understand really what 50 to 75% of the universe is made from. That's the dark matter. We don't really understand what it is, where it comes from, how it interacts. So it's finding out more and more about the universe that's key here.
Okay, so the theory, I mean, the premise stands, but it's filling in the picture. I see. Um, Now, can you give us a profile of the Dell server and cluster technology that you have in place?
Yeah, so we've got a couple of generations of system at the moment, which are provided by Dell. So we have a system that was installed in 2018, which is Dell C, the half node, half U chassis, so 4 chassis in 2U. That's the 4 nodes in 2U. That's the C6420 series. And it's getting on for 500 nodes of that. Then our newer system was installed just last year in 2021, and that's again similar servers, 4 servers in 2U, and they're the Dell C6525 series with AMD EPYC chips inside them. These are the ones with a terabyte of RAM per node. We also have a smaller, a 24 node test cluster as well, which we use for testing novel technologies. So that's where the blue field tests have gone on. That's where the Rockport tests have been going on, and where, given the success of that, we're then looking at converting half of COSMA 7 into this Rockport stuff. So in terms of the Dell kit, it provides all the service for this. It also, we use the Dell hardware for our storage as well. So we've got multi-petabyte Lustre file systems, which again is running on Dell hardware.
Okay, and tell us about your Center of Excellence partnership with Dell and the value of that to the organization and developing your HPC infrastructure. I would assume in terms of selection of technology, the infrastructure strategy.
So one of the key things that it gives us is access to Dell engineers. So we're able to get a feel for what's coming. So this is one of the reasons why we were involved with Rockport. It was before they went public. Dell put us in contact with Rockport, and through this Center of Excellence, and we were able to then to start testing that sort of kit. So it really gives us early insight into new technologies, new interesting technologies, things that are useful for us. And by doing this as well, we're able to feed back to Dell how useful this sort of kit is going to be, and where we think where we would like future technologies to take us. So it's a two-way thing with benefits for both parties.
All right. Well, it's been a pleasure. We've been with Dr. Alastair Basden, head of the COSMA HPC Service at Durham University in the UK. Alastair, thanks so much.
Thank you.